Okay, so this is Algebra 1, Unit 4, Learning Target 9 Notes. Word problems. Slope-intercept form. Okay, so let's kind of take our walk through this here. And here's kind of the good news is we've done word problems before, or we've done slope-intercept problems before. So let's write y equals mx plus b. You should be so familiar with this form by now. Okay, you know that the y-intercept and the slope are represented by the m and the b, right? So kind of off to the side here, let's take a look at and write this up here. So your m is your slope. And if we were just talking about like a regular old problem on a graph with no words or stories to go along with it, we would refer to it as slope. It's the slope. It's the rise over the run. It doesn't mean anything, okay? When we have story problems, we don't say slope because it has a meaning. We call it rate of change. So do you remember we did this before? Rate of change. What is it changing by? I don't remember what unit it was, but so slope can also be called rate of change. Yes? All right? So like if water is evaporating from a bucket of water that's sitting in the sun, the rate of change would be how many milliliters of water is evaporating every day. Do you see what I mean? It's changing by an inch every day or so on. So then the B represent what we call the y-intercept. And when we were just graphing, the y-intercept didn't really mean anything. It meant that's where I start graphing my line. That's all it meant to you. So when we're into word problems, we don't call it y-intercept. We call it, anybody remember? Good. Initial value. It means where are you starting at? So if I were to talk about, joining Planet Fitness, it's $30 registration fee. And then $10 a month. Okay, so when you hear something like that, by now you should just be thinking, oh, okay, so X, Y, and this is something that we're going to do today also. We're going to be creating kind of like a little mini table, but we're going to put two columns to the left of the X and the Y because I want to know what does X stand for in that Planet Fitness example. X is almost always, it's always your independent variable, but it's almost always your unit of time. So if I give you a story problem about how many months, how many days, how many years, how many weeks, that's going to be your X. So this is the number of months in my Planet Fitness example, and this would be my cost, how much money it's cost me. So let's say I don't even get out there and lift one weight or jump on one treadmill. How much money have I paid this place yet? Already. $30. Because they don't even let me come into the gym until I've paid that initial value, right? But on that first month, I will have paid them, how much total? $40. Because after that first month, of that $40, $30 of it is what it cost me to join, and 10 of it, right? So then, let's say after month 2, I will have given them a total of $50. Now, somebody who doesn't understand this initial value right here and what it means might just look at this chart and say, oh, 2 months costs $50. That must mean it's $25 a month. And that's wrong, right? So that would mean they didn't look at either of these points. So this is your rate of change. So do you understand that? Okay, because we're going to do a little bit with that today. So let's take a look at number 1. So Lynn is tracking the progress of her plant's growth every day, starting today. So today the plant is 5 centimeters high, but every day that she measures it, say at 5 o'clock every day, just so she knows it's consistent, she remeasures it. So why do I have 2 highlighters? And what do you think is the important information that I'm going to need to know? So I'm going to use, for me at least, yellow for my initial value. So which one is my initial value, 5 or 1.5? 5. So I'm just going to highlight 5 centimeters. And then that means that my rate of change would be 1.5. centimeters. Okay. So here I have 3 things listed. The equation, a table with 3 points, and ordered pairs. So let's do one of these things at a time. I know that you know already, like, what this equation would be, right? So go ahead and write it. Write what you think that equation would be. Because, by the way, the equation for the Planet Fitness was $10 a month plus 30. So you knew that, right? So now write your equation that you think, bless you, would fit this. And my guess is that you wrote y equals 1.5x plus 5, right? Raise your hand if that was it. Almost 100%, right? Okay. Now, is this also right? Now, here's what's kind of weird about this, because some people, when they do these word problems, they are literal, meaning they go exactly as how they read it. So they'll say, the plant was 5 meters tall, or 5, that would be huge, 5 centimeters tall, and then it grew 1.5 a day. Is that okay? Sure. That is kind of exactly how it happens, right? So this is kind of how it happens. It was this, and it went up this. But you're so familiar with this form, aren't you? Is it okay to put it this either way? Absolutely. If this is what's more comfortable with you, that's okay. So now, here's what you're going to do next. So there's our equation, just like I asked you to do, right? Now, here's also let's do this. I'm going to come back up to the equation in a minute, but let's make our table. X and Y. All right. So now this is where I'm going to get this other color here. I want to know what variable X and Y stand for. So if I were to eventually, like I will, not today, ask you to graph, like if I asked you to graph what it would look like for your Planet Fitness example, first of all, I would only need quadrant 1, right? Because it's time and money, and I mean, you can have negative money. I guess you could owe somebody. But, so if this was my X, which was the number of months, and this was my Y, which was the number of, this is the Planet Fitness example, by the way, the dollars that I owed, I would start right here by owing them 30, right? And then where would my line go? It would go up, because every month I owed them $10 more, right? Okay? So the key is I needed to know that X was the number of months and that Y was the dollars. So, and remember what I said about how X is almost always the time? So kind of separate in your table, what 2 words are you going to put there? And here's what I do. I circle them. Day and centimeters. And you can almost always find what 2 words you're looking for by looking immediately after the number. 5 represents centimeters, 1.5 represents days. And what did I say about your X value? Is usually your independent variable, which is time. So I'm going to put D for days. And centimeter, cm for centimeters, or C in your equation. Okay, because now watch this. This is something new. In a minute, I'm going to ask you a question, because read this. You got your equation. What is the height of the plant, I should say plant, after 20 days? Okay? So what you're thinking then is, shoot, I don't know where to put 20. Do I put it in for X or do I put it in for Y? So I have a solution for you. Do you agree that X is the number of days and Y is the number of centimeters? So watch this new improved equation. Instead of Y equals 1.5x plus 5, I'm going to actually write that the number of centimeters it is 1.5 times the number of days plus 5. So C equals 1.5D plus 5. It doesn't look like anything that you're used to, and I know you're probably thinking, nope, I'm going to use X's and Y's. I like that better. This is too confusing. But you're not always going to see X's and Y's. And then you're going to go, what does that mean? So do you understand how I just kind of used this table to say that the Y really means centimeters and the X value really means days? So now watch. When I ask you this question, what will the height of the plant be after 20 days? 20 is D. So I put it there, right? Do you see what I mean? How it makes it easier? Because I may go, oh shoot, X and Y, where do I put the 20? Well, 20 represents days. So you're going to put it in there, and there's no question about it, right? So before we do that, let's just kind of finish our table. As we're going with this here, on the first day, or actually before the first day, before she even decided she's going to measure it, how tall was that plant? It was 5 centimeters, right? Then at 5 o'clock on the very next day, on day 1, how tall was that plant? If it grew, yes, so 6.5 centimeters. On day 2, then it would be 8, and that's enough. So write a table with 3 points. We just did. Make always one of them be 0. 0, 1, and 2. Your table is done. Got it? And this is really important. I want you to include those words there. All right. So then, now what I have to do is answer this question. What will the height of the plant be after 20 days? So now I know that that 20 goes right there. Yes? So this means that the centimeters, the number of centimeters, will be equal to 1.5 times 20 plus 5. And 1.5 times 20 is 30 plus 5. So C equals 35. Okay, so we're not done yet. I know C stands for centimeters, so I know that represents 35 centimeters, not 35 days. But I want to take a look at this thing right here. Ordered pairs. What's she talking about? So let's go back up to this Planet Fitness example for a second. So I already have it labeled. So, side note, Planet Fitness. So X, Y, right? In my Planet Fitness example, what was X? It was the number of months. And what was Y? The cost. So, when I found out that month 2 costs $50, do you know what 2 comma 50 means right away? It's not just some random point on a graph to you. You know that if it's in the first spot, it's the number of months. If it's in the second spot, it's the cost. So 2 months at Planet Fitness are going to run you $50. So you know what that means, right? Right away. It means the joining fee for 0 months is $30. So let's do this. Let's get back to our plant example. What is your X? X is the number of days. And you could use H for height if you want, but we're using C for right now. So I know that it's days comma centimeters. So now what can I do with this and this? What ordered pair will I create from finding out that 20 days later it's 35 centimeters tall? I just said it. 20 days later it's, okay? So these ordered pairs are really important because later we're going to go back and graph these. So it would look like this. Number of days and the number of centimeters. It started out at 5 and then it grew 1.5 a day. Got it? And somewhere on that line is 20 comma 35. Do you think I can see it? No. Because here's the deal. There have been people, I promise you, in the past, in order to answer this question, they will make their table go to 20. And they will go 3, 4, 5, 6, 7, 8, and then we'll add 1.5 every single time. That is not necessary. We use algebra. We put a 20 there, we multiply it by 1.5, then we add 5. Got it? Okay? So are you good with that example? Okay, because let's move on to poor Mr. Thompson's dog. His dog is so big, he needs to go on a diet. He's 260 pounds. Yes. And his diet is so successful that this dog ends up losing 4 pounds every month. So I want you to write an equation. We're going to go through this exact process. We're going to write the equation, the table, and the ordered pairs to show this dog's successful diet. So, highlight. What is the dog's starting weight? And what is its rate that it's changing by? So, go ahead. 260 pounds is what it's starting at. And what word should you highlight in with 4? month is good, but what else? He's losing, right? So loses, because what is our, because when I go right here, he's starting at 260, but his rate of change is what? If his rate of change is 4 pounds, he's gaining weight. Yes. Do you see that? So that's why loses is pretty important. So, step 1. Y equals, now stop before you write your equation. But actually, you know what? Write it. I want to see what you do. Because this one's kind of tricky to write. So some people would look at this and say, it's just weird. It's just weird because I want to say that this dog is starting out at 260 pounds and then losing 4 pounds a month. Totally okay. Does anybody write it like that? Right? It's hard because your first instinct is to put the slope first, but for the story of the problem, it just makes sense to start with that 260 and wait. So did anybody put y equals negative 4x plus 260? So we're comfortable with that, and that's okay. Whatever way you want to do. Now, we need to take P for pounds and M for month. Which one is which? And to help you write that new equation with those new variables, I start the table first. If I were to graph this, what would my x be? X is your time. So what am I going to put right here? I'm going to use M for months. And I'm going to use what? P for pounds. So now that you know that, go rewrite yourself a new equation. So don't use an X and a Y. Garrett, stay with us. That's not homework anyway. So Y is pounds, X is months. So, and here's the deal, guys. Don't try to memorize it. Just think about it. Isn't his number of pounds equal to negative 4 times the number of months he's on that diet plus his starting weight? Like, I just kind of said a sentence and wrote as I said it. He weighs negative 4 times however many months he's on this diet for, but he's got 260 pounds to start with. Okay? So on month 0, the day before he's supposed to start his diet, he hasn't even started the diet yet. How much does he weigh? So after the first month, his owner weighs him on the 31st of January, and he weighs what? Yes. And at the end of month 2? Yes. So it's a slow go, but he's in it for the long haul. So do you understand where we're at? So now my question is, his dog weighs 160 pounds now. How many months did it take him? So, do you see how helpful it is to have the P and the M? Because otherwise you'd be like, where do I put 160? Do I put it in for X or Y? Well, 160 is your Y value because it's your pounds, so I'm putting 160 where? Right here. So watch this. And I know that this is one that you could do in your head easily. I know, because he's 100-pound difference, right? And if he's losing 4 a month, but they're not always going to do them in your head like this. So I know what you're thinking also here. You're going to have a negative 100 pounds, but that's okay because you're going to divide it by a negative 4 months, and that's going to work out to be positive. Okay. Now, what I probably should have done before I went up and did this is, what is this? Is this M comma P or P comma M? X's, M comma P. So every ordered pair I see, I know that it's the number of months on the diet and the number of pounds that he weighs because of it. So what do I do with these 2 points? Is it 160 comma 25 or 25 comma 160? So 25 months into the diet, over 2 years later, he gets down to 160 pounds. Got it? If I were graphing this, X is the number of months, Y is the number of pounds. What's going to be different about this one? Where's his starting weight? All the way up here. What's happening with this line? He weighs less each month, right? So this one's going to go down. Will it ever get to the x-axis? I hope not. Well, then he would just even his... So at probably what's going to happen somewhere here is instead of this, do you think maybe, you know how, what if this poor dog is on a yo-yo diet? Did you ever hear that? He's going, his weight's going up and then down, and he does good, and then he gains more weight, and he eats too much puppy chow. So he could go back up, right? So it probably will never get to the x-axis, because then that will mean he doesn't weigh anything, and we don't want him to not weigh anything. Yes, we won't talk about that. Okay, does that make sense? All right, take a look at 3. Go ahead and read 3 for me.